So at the latter half of yesterday, we began talking about functions, which we described as pretty much being like a machine, right? You throw in an input and an output emerges from the machine. So we're just going to wrap up that conversation. I'm going to demo a slightly more complex function, but there's nothing here that we don't already know about. At the end of yesterday, we created a function that adds together the first two items of an array. So I guess let me just start by rebuilding that. We'll just comment this out for now. So we wanted to create a function. We'll call it, I don't know, the adder machine, or the adding machine, which will accept an array. So just reminding everyone about this thing here is the name of the variable. So when the input goes into the machine, into the function, this becomes the nickname for that input. I can name this whatever I want, but I decided to call it array input. Before we build the internals of the machine, let's demonstrate how we intend to use it. I would like to throw in a single array as input into this machine, into this function. And I want the output to be the sum of the first two numbers of this array. So I want the output should be 3, because that is the sum of 1 plus 2. Right? This is the last thing we did yesterday. So the way we achieved this is we said we'll make a new input, a new variable rather. I'll call it output is array input 0 plus array input 1. Recall that we also learned about arrays yesterday, so in order to grab the first item from an array, you reference the array and follow it with square brackets and a 0. That gets the first item from the array, and then array input 1 returns the second item from the array. We're going to take the sum of those two numbers and make that sum, we'll give it a variable name called output, and then we return that output, because every function always returns something, right? Like the Sneetch machine, something always goes in and something always goes out. So if we run this, we get a syntax error because unexpected keyword end, because I wrote function and it should be def. In JavaScript, it's function. So, and now we get 3. So, yeah, just got another message. Someone else is running late due to the rain. So that's why there's video. So sometimes it's hard to get back into things, to jump right back in. So that's why I'm showing this example again, which demos, again, the concept of arrays and the concept of functions put together. Any questions about this? Okay, so the more complex function that I'm going to demo now is a function that returns the sum of all the numbers of an array. So this function just returns the sum of the first two numbers of the array, but I want the sum of all of them. So we could actually still call our function adding machine, because that's still a proper description for it. Just now it's going to add all the numbers. And in this case, so I'm gonna wipe, well, hold on to that one second, but the output that I want should be 1 plus 2 plus 3 plus 4 plus 5, which is 15, I think. Okay, that's where we're headed. Now, I could, and this is probably what people are thinking, I could solve this problem by extending what I've done as follows. right? This is a proper solution, right? Just because I want to add all 5 numbers doesn't really make this more complicated. I just have to add more things. But here's the catch. What I want this function to be super flexible, and I want it to work for arrays of varying sizes. So if I kept this function as is, but threw into the machine an array that only had 2 items in it, it will break because it's trying to add things that aren't there. If I added a 6th thing to this array, it wouldn't break, but the answer wouldn't be correct because it's only adding the first 5, giving me 15. But I want a function that adds all the numbers, no matter how many numbers there are inside this array. Really, the output here should have been 21. So that's the challenge. I want to make a function that is super flexible. It will add up the sum of all the numbers of an array, no matter how many items there are in the array. Does that challenge make sense? It's formidable. So let me show you how one might approach it. Now, again, there's no new concepts here. Everything I'm going to show you are concepts that you already know. It's just, the putting of all these things together. So we're going to use a loop. That's sort of where we're headed. We're going to use a loop to go through each of the numbers in the array. And as we go through each number, we're going to be adding it up. So let's put this function on a commercial break. We'll come back to it. And let's solve this problem outside of the context of a function. Sometimes it's hard to solve a complex problem as you're building the function. So what I'm going to do here is sort of solve the complex problem without the function, and then we'll plug it into the function. So let's start over. Let's make a variable called array that is going to have these 6 numbers in it, of which the sum, if we actually added all those numbers together, we would get 21. I would like to write code that will loop through this array and give me the sum of all these numbers. So I'm building this up slowly. Let's work with the fact that we know that there are 6 numbers in this array. We'll change this shortly. But because I know that there are 6 numbers in this array, I'm going to make a loop that runs 6 times, because I'm going to go through all 6 numbers inside this array. And I want to create some sort of variable that keeps track of the sum as I move through all the variables in the array. So I'm going to make a variable called sum. And I'm going to start it out as 0. We did speak about the other day how in many different algorithms where you're trying to keep track, especially of something like a sum, in many cases you end up needing a variable before the loop begins that starts at 0. The idea here is we're going to loop through this array, and as we loop through it, we're going to add the number we're up to the sum. So something like sum equals sum plus the number we're up to. Now, in order to effectively loop through an array, this is a trick we learned yesterday. We can make a variable. I'm going to call it index. And I'm going to start index out at 0 as well. The index keeps track of which index we're up to in the array. If you'll recall from yesterday, every slot inside the array is called an index. So this is, the 1 is contained within index 0, because remember arrays start at 0. The 2 is contained in index 1. The 6 is contained at index 5. So as we loop through the array, we're going to increase the index by 1. Let's put that on hold for a second. If I want to print out each of these numbers, I could say p array brackets index, and that will print out all 6 numbers. And again, the way this is working is let's follow this through. So before the loop begins, index starts out as 0, right? So when we say p array index, that's as if we say p array 0. which array 0 gives us the first item in the array, so it prints it out. We then increase index by 1, and we start the loop for the second time. Now when index is 1, when we say p array index, it's as if we say p array 1, which will give us the 2. So that's why the 2 prints out to the terminal. Then index increases by 1, so now index is 2, and we start the loop a third time. We say p array index, which is if we said p array 2, and that returns that prints out the 3. Does that make sense, how we use this index variable to help us progress through the array? We start the index variable out at 0, and we keep on increasing it by 1, and then we check each item in the array by saying array square brackets index. So we say, it's as if we say array 0, array 1, array 2, and we can effectively loop through the array. Does that make sense? That's one of the big tricks of arrays, is the ability to loop through it. And you always achieve that through an index variable like that. So now instead of printing it out, really what we want to do is say, we don't want to print these numbers out, we want to add them to our sum. So we say sum equals sum plus array index. Because before, let's follow this through. Before the loop begins, sum is 0, right? Let's keep a comment here to track which, what index is up to and which round of the loop we're up to. So let's start the loop for the first time, right? 6 times do. So sum equals sum plus array index. So since index starts out as 0, when we encounter line 9 for the first time, it's as if we say sum equals sum plus array 0. What is array 0? 1. So we say sum equals sum plus 1. So let's keep track of the sum as well. So the sum is now 1. We then get to around line 11, which increases index by 1. And now we're up to loop round 2. We start again. Sum equals sum plus array 1. What is array 1? 2. So the sum has now increased by 2, so the sum is now 3. And we increase index by 1. And we begin again. Basically, just like before, as we went through each round of the loop, we printed each of these numbers. All we're doing here is, as we go through each round of the loop, we're adding each of these numbers to our sum. Again, pointing out what I like to point out often is that talking to computers is different than talking to a human. When I talk to a human and I say, hey human, can you please add up all these numbers? What you would do is you would start with the 1, and then add 2 to it, and add 3, add 4. But what we're doing here with the computer is we're actually starting with a 0 and telling the computer, add all these numbers to your 0. That's just that's just how, when using a loop, we have to get this to work. Does this make sense? Okay, so this is, now what's really cool, well, I don't know how cool it is. Now if I added a 7th item to this array, this would not work unless I now change the loop to be 7 times, right? So this code is not we have not achieved that flexibility that I'm looking for. Because as we change the number of items in the array, we're going to have to change the number of times we run the loop accordingly. Okay. Now, let me show you, this next trick is new. This is actually a new concept. It's the one new concept we need. I want to show you a way in which I will never have to change line 9 ever again, no matter how many elements there are in this array. So I'm going to introduce this trick of flexibility. There's a cool little trick that we can see how many items there are inside an array if you do the following. Let me comment this out for a second. P array.length. So this is a new little trick. if you see when we say array.length, when we print that out to the terminal, we get 7. The length of an array is how many items there are in the array. If I add more items to the array, so now there are 10 items to the array, array.length gives me 10. Okay? With this little trick, we can achieve the flexibility we want because I'm going to bring back my loop. Instead of saying 7.timesDo, I can make a new variable called number of loops and set that to be array.length, because the number of loops that I want to run are going to be as many items that there are in the array. And then instead of 7, I could say number of loops, which is just a variable for array.length, which in turn is the number of items in the array. We should print out the sum at the end. Okay, so this is sort of an earth-shattering concept. This is new. This concept of array.length, which returns, it gives me the number of items in the array. I set that to a variable called number of loops. And now instead of saying explicitly a number over here, 5 times do, 7 times do, 10 times do, I put in this variable, which changes based on how many numbers there are in the array. So now I can have an array that has just 5 items in it, and my loop will end up running 5 times. And I can have, I can have 11 items in the array, and my loop will run 11 times. So I've introduced this amazing level of flexibility that this code will effectively add up all the numbers from my array, no matter how many numbers there are in the array. Does this make any sense? Are there any questions about this? Chris has a question. You could talk, Chris, if you want. Yeah, so Chris has a good question. We could, I did this to make it more explicit, but we could technically go right in here and say array.length.timesDo. And that would also, since array.length would give me, let's say 11 in this case, that would work as well. I decided to go this route to make it, in my head this is a little easier to understand, but Chris, you are correct. That would work too. Okay. Any other questions about this? Now to tie this all back to the original question is, I want to create a function that does this. Right? This is code that starts with an array and adds it up, and we're very, very close. But how do I build this into a machine that you can throw in the array as an input, and as the output, it returns the sum? So at this point, we're pretty much done. We're just going to build our adding machine again. It's going to accept an array input. Again, to demonstrate its usage, can everyone still see this in the back with the smaller font? Yeah. To demonstrate how to use it, we would use it like this. We throw in an array as the input into this machine, into this function, right? So now we basically put all this code into the function. We can't do this blindly, but we start with a sum of 0, start with the index of 0. We get the sum. We could say output is the sum and then return the output. And when we run this, it doesn't work because because here, right, let's read the error message. Error message on line 4. Undefined local variable or method array. Did you mean array input? They even guessed what I meant. So on line 4, we say number of loops is array.length. Ruby says, I don't know what array is. And they're absolutely right. In our earlier version of this code, we had a variable called array, but we no longer do. What we do have instead is the array input. So I'm going to change this to array input, and I'm going to beat Ruby to the punch by changing that one too. And now, when we run it, it works. So when we throw in this array of the numbers 1 through 11, our function, our magical machine, adds up all the numbers and returns the output of 66, because that is the sum of all the numbers contained within the array. And again, it's super flexible. I can throw in a whole bunch of numbers. I'll throw in a negative number, and it will still work. So this is the beauty of a function that is a flexible machine. You can throw in any input, and it will perform a proper calculation no matter what, and return you the output with your desired result. Yeah, Joseph?
So the sum right under the first line is the
So give me a line number.
Second line of code.
2?
Yeah, so
Yeah.
that indicates the first index? Is that,
So-
the index indicates the first index, which is 0, but why is the sum 0? Because
Yeah.
we haven't added anything yet?
Exactly. So this is sort of the tricky part of talking to a computer. Like, if I was saying, hey, Joseph, add these numbers, you would start with 1, right? But to tell the computer, add all these numbers, our trick for doing so is saying, okay, computer, start with a 0. And now, as we loop through each one, add all these numbers to that 0.
Just being clear where the starting place is, which is...
Yeah. We have to start somewhere, because if we didn't say this at all, basically, on line 7 would blow up, because we're saying sum is sum plus array input index, but this sum was never defined anywhere previously. So we have to define sum previously, and if we'll have to give it a number, we have to start it out at 0, because when we're going to add it, if we give it any other number, the result would be faulty, because it's going to be adding all these numbers to 5, which we don't really want in this case. So this is sort of, this whole trick of starting a variable off at 0 before a loop is a very common trick. Anytime you're keeping track of like a sum of anything, you pretty much find yourself doing that. But yeah, this index is a totally different variable. This is keeping track of which slot we're up to in the array as we loop through it. It's coincidental that they both start at 0, but they're two totally different concepts. I will save this and Slack this to you so you do have it as a reference. Any other questions? Again, there's still this gap of like, I could show you how to do it and it makes sense, but then I can ask you to do this similar thing and it's really tough. Again, this stuff takes a ton of practice. Okay, let me demo another, somewhat complex example. Let's start a new file. I'm going to make a double array machine, which is going to accept an array as its input. What do I mean by that? I want to make it that if I throw an array into the double array machine, it's going to give me an output of a similar array, except that every number in the array is doubled from what it was before. So if I throw in 1, 2, 3, 4, 5, I want to get an array back that is 2, 4, 6, 8, 10. Because 1 doubled is 2, 2 doubled is 4, 3 doubled is 6, etc. So again, in real life, would you ever need a function like this? Probably not. But the idea here is we can make functions that do anything. So this is sort of, like the Sneetches one, right? Like a starless Sneetch in and a starful Sneetch out. So an array in and a doubled array out. It's this magical machine that we're creating. Cool, that's the challenge on the table. So let's So let me show you another trick. Again, I don't think we're going to learn any new concepts for this, but it's more about like, you know, tips and tricks for dealing with these types of challenges. So just like what I said, so one trick we mentioned before is anytime you want to keep track of a sum, starting with a variable that starts out at 0 is a good trick to keep in mind. Anytime you want to do something like this, namely that you want to take in array as input and come out with some other array as output, very often you want to, before you start any loop, you want to create a variable that's going to be your new array that you intend to be your output, that you start out as a blank, empty array, an array with nothing in it. So the approach we're going to take here is that, again, we're going to loop through each of these numbers, but as we loop through them, we're going to double each number we encounter and shovel it into the new array. So by the time we're done, we will have this newly constructed array that is based on the data from the input array, but it's new. Does that make sense? So really, there's two approaches we could technically take. We could try to take the original array and go into it and change each number and double it, but that's usually harder. This approach I'm taking is we're going to make a new array from scratch. It starts out blank. It's a list with nothing in it. And then we're going to, as we go through look at every item in the original array, we're going to throw in a new item into the new array and build the new array as desired. So let me show you what I mean, instead of just talking about it. So we are going to need to make a loop that is going to go through each of the items in this array. Now, since, once again, we want to make this function flexible and work no matter how many items there are inside the input array, we're going to do that same trick as before, where we're going to say number of loops, we're making a new variable, is going to be the number of loops that we do is going to be determined by the number of items that there are in the input array. So if the input array has 5 items, we're going to run a loop 5 times. If the input array has 10 items, we're going to run this loop 10 times. And once again, we're also going to have an index variable that starts out as 0 to keep track of where we are in the loop as we go through it. So let's do our loop. Number of loops times do. So as Risa, can you let Kale up? Thanks. Hey, Sam. Can you hear me? Sam just joined. Can you hear me, Sam?
Yeah, I can hear you.
Okay, awesome. So you can stay on mute, and then just feel free to pipe up anytime you have a question. Okay, so continuing our example, the strategy here is we're going to loop through each of the items in the original array. To do that, like every other time we do this, we are increasing index by 1. Now again, just to show everyone what would happen if we simply print everything from the input array. Again, this is not our goal here, right? Is everyone, I want everyone to get very familiar with this pattern of the looping through an array. The way we loop through an array is you start a variable out at 0. I like calling it index. You have a loop that every time you go through the loop, it increases index by 1. In this example, I'm simply printing each of the items of the array. So we see the 1, 2, 3, 4, 5 come up here. The reason why there's an extra 5 here is not something I'm going to explain right now. But it's basically because of this, because we haven't finished doing what we're doing. But my goal here is not to print this out. Instead, my goal is to create a new array that doubles everything from the original array. So let's do it this way. I'm going to say new array. So this new array is this blank array that we established on line 2. We're going to shovel into the new array the number we're up to inside the original array times 2. So let's walk through this. We're not done yet, but let's walk through this. Again, our goal here is that we're throwing in this function, an array. In this example, it's 1, 2, 3, 4, 5. And the desired output is a doubled version of this array. So 2, 4, 6, 8, 10 in this example. So we started a new array out on line 2. And as we go through this loop, we check the input array index. Since index increases by 1 each time around, so input array index starts out as input array 0, and then input array 1, and input array 2. Basically, going through each of these items, right? Input array 0 is the 1. Input array 1 is the 2. Input array 2 is the 3. We're basically going through each of the items in the array. We multiply it by 2, and then we shovel that result into the new array, throwing it at the end. Recall again that when dealing with the shovel operator or an equals operator, everything to the right of it processes first. We take that result and then throw it into the whatever's on the left-hand side of the shovel operator. So Ruby first processes array index times 2. In our first round of the loop, when input array index refers to the 1, this is as if we said the number 1. So 1 times 2 is 2, and we throw that into the new array. The next round of the loop, where index is 1, it's as if we said input array 1 times 2. Input array 1 is 2. So 2 times 2 is 4. We take the 4 and we throw it into the loop. So by the time we're done, the new array should be filled with basically the doubled values. So we can say output is new array and then return output. And this actually works as intended. My point here is just to demo some more complex examples of functions. So again, the function here is the double array machine. The idea is we throw in an array, and we want a doubled version of it. So let's try another example. I'm going to try 5, 2, 1, 17, -6. So if I run that, that works. I could throw in as many items as I want. And again, my function is flexible because of this trick I showed you today of the number of loops times, which we got from the input array.length. Again, each time we go through this loop, we go through each number in the array. We take its doubled version, shovel it into the new array, which started out blank. But as we go through it, we're shoveling new values into the new array. We eventually return that new array as the output of this function. It's, again, a complex example. Yeah, Shane?
Just to make sure I'm kind of understanding things behind the scenes correctly.
Yeah.
If we want to simplify the syntax of this a little bit more, instead of defining output is equal to new array, we just have it return new array and still get the same data.
Yes, that is correct. We could simply say return new array, and it does the same exact thing. I'm just, for the sake of really driving home the concept that an array always has an input and an output, I'm making this a little more explicit. Programmers in day-to-day life will do it your way, Shane. They won't do what I'm doing here, but I'm trying, for the educational piece of it, I'm making it super explicit. That we're saying this new array that started out as blank, but by the time we got through the loop, we added all the doubled values to it. That new array is now going to be our output from this function. Questions about this? And again, like I keep on saying, this takes practice, right? I can show it to you, and you're like, yeah, I get it. But just like I could show you how to play a flute, and you're like, yeah, I get it. And then I hand you the flute. It's hard. This stuff is hard. But you get good at it when you practice. Believe it or not, you could get really good at this. Any other questions about this? I will. Let me save this as well and Slack it to you so you have it as reference. And now I'm going to throw a bunch of hard exercises at you. However, you're going to pair up on it. And this set of exercises is brought to you by Kazakhstan. We need to... Kazakhstan is ramping up their cyber warfare efforts. And I'm going to, again, I'll Slack you the link to Kazakhstan. So this time we're going to stop their virus development. Now, I don't know exactly how viruses really work, but I know that they're bad. And I know that we need to stop them. So you're going to pair up. Each of these exercises is going to ask you to create a function, because that's obviously how you stop viruses. And you basically what it's looking for is you're going to be actually creating a function called virus, with something there in the parentheses, and you're going to create this function based on what it tells you to do. And the computer is going to check to see if your function works, because it's going to try different values. It's going to throw different values into your machine and check if all the different outputs it expects are correct. Does that make sense? So if you make like a double array machine, it's going to throw in a bunch of arrays and check that they all double properly. So yeah, these exercises are difficult. They're difficult. And that's how we're going to pair up. I mean, if you pair up, you still may not get it, but that's cool. Now I know, so I guess Sam and Chris, since you're online, I guess either you can find a way to pair up with each other or you can do them individually. And I guess are we in I'm not good at counting. We're an even number of people. So I guess you can all pair with your adjacent person. And yeah, let's stop Kazakhstan before they put viruses in everyone's computers. Let's demo these virus exercises by using Replit. So the first function that we have to write is a function called virus that accepts an array of numbers and returns an array containing all those numbers, but only those that are greater than 7. So let's do that. So we know that we're creating a function called virus. Let's demonstrate how it will be used. So we're going to throw in, if we throw in that array, the expected output would be 8, an array of 8 and 9. Does that make sense? At least now. So to build this machine, to build this function, we're going to need some sort of variable name to receive the input. So whenever the input's an array, I tend to call it something like this, input array. But you can call it Fred or Lisa, which is one of those three things, input array, Fred, or Lisa. And we know that we want to return an array based on this. So again, the trick that I like to use whenever we want a function that returns an array is to start with some sort of new blank array and throw things in it. In theory, just another strategy might be to go through this array and delete all the items that are 7 or less. And that might work, but that's harder. It's usually easier to start with a new array. So I'm going to create a new array called new array. Start it out as a blank array. And again, we want to do that same thing of where we have a flexible function that accepts arrays of all lengths, meaning arrays with all different numbers in it and different numbers of numbers. So we're going to do that trick again of the number of loops is going to be the input array.length. So we know the loop that we are about to write, it's going to run as many times as there are numbers in this array. So let's do that. Number of loops times do, meaning we're going to run this loop for as many items as there are in this array. So if there are 5 items in the array, that means we're going to run this loop 5 times. So we want to loop through the array. Again, the trick to do so, again, this trick you can always pretty much, I don't know, always, many times rely on is have a variable that's called something like index, right? And then change that every time you loop. And this way you can inspect every single item in the array.
Index basically just stand in for any element
Index,
in the array or argument or whatever.
index refers to which spot I am up to in the array as I look at each item.
Right.
Because that is, and again, this I could also call Fred, but I call it index because that is the legal term, if you will. That is the jargon for referring to, this is the 0th spot in the array.
Right.
That's the 0 index of the array. That's how you call it. So that's the index we're up to. So as we loop through the array, I want to increase the index, right? Again, if I wanted to just simply print each number from the array, it would look like this, right? P input array brackets index. But I don't want to print it. Instead, I want to add it to the new array if that particular number is greater than 7. So if input array index is greater than 7, then let's shovel this input array index into the new array.
You forgot to put the shovel sign.
Thank you. So we want to shovel the input array index into the new array. So pop quiz, if index is 2, what is input array index?
That's me 6.
Close. If index is 2, what is, it's 7, right? Because the index starts at 0.
Yep.
So input array 0 is 5. Input array 1 is 6. Input array 2 is 7. So as index increases, input array index refers to each element in the array, one at a time. We're checking each one at a time. If it's greater than 7, we shovel it into the new array. And then we increase index by 1 each time we go around through the loop. We'll make a variable called output, which is going to be this new array, and then we're going to return that output. And it seems to work. Let me get rid of the green things. Yeah, it seems to work. It's tricky. It's tricky to piece this all together. Any questions about this? Okay, let's move on to the next one. Oh, let's put it in. Let's stop that virus. This thing really could give you a seizure. Okay, virus 2. Fill in a box with a function called virus that accepts an array of numbers and returns the number of 55s in the original array. And for future cohorts of this class, I've already put in a new, you can't see it here, but it'll be an example to make it clear. So let's spell out what we want to do here. Yes, I can Slack that. Thank you. I'll Slack that to general. Now moving on to our new virus. Again, this is not how viruses actually work. Now, I don't know how viruses actually work, but I know it's not this. So the idea of this virus is that if the input is something like this, there are 2 55s in this array, so the output should be the number 2. Okay, we're not, in this example, the output of the function is not a new array. It is simply a number. The number of 55s that are in this array. Cool? So, again, this is going to accept an input array. And we're going to go through a lot of the same tricks that we did before. We want to, our strategies, we're going to loop through We're going to go loop through each of the items in this array, and we're going to count up the 55s. That's how we're going to do it. So to keep track of how many 55s there are, we're going to make a variable called count. That's the count of how many 55s there are. What should I start this variable out at? 0. Again, this is one of those tricks that whenever you want to keep track of a sum of something or something like this, very often you want a variable that keeps track of it that starts out as 0. We then are going to want to have a loop that goes through our array. Since we want to make this function flexible and work for arrays of all sizes, of all lengths, we're going to do that same trick as before. Number of loops is going to be the input array.length. We're going to run that loop for number of loops times. So in this example, if where we have 7 items in this array, then that means this loop will run 7 times. If it has 8 items in this array, then the loop will run 8 times. Again, the trick to check each number in the array as you loop through it is this index trick, where we have index is 0, and as we run through the loop, we're going to keep on increasing index plus 1. Now, this is where the real logic comes in. As we loop through each of these numbers in the array, basically what we want to do is if we encounter a 55, we're going to increase count by 1. So exactly what I just said in English, I'm now going to express in Ruby. If input array index equals, remember those double equals, 55, then count equals count plus 1. By the time we get through this loop, the count will be hopefully where we want it to be. So output is count, and then return that count. And let's see if this works. We get 2. Let's just test it out with, let me throw in 2 more 55s in there. We get 4. Questions about this?
So it doesn't matter whether you put return output or return count?
Yeah, this is really longhand. I mean, I don't know what you call it, but yeah, I could. Oh, I'm sorry. I meant to say, good point, Evelyn. I meant to say return output here. But yes, I have 2 options. Like I could say return count, because basically whatever you say return whatever, that whatever is always the output. Return is that magic keyword for functions. So I could really just say return count. Just for this class, I like making it more explicit, where I set this count to be this variable called output and return the output. That's what I meant to write. But yeah, I could just say return count. In the real world, developers will just write return count. So this is more of an educational tool. Great question. Other questions about that? Yeah?
What shortcut keys are you using to uncomment things? I've noticed you can uncomment.
Yeah, it's actually the same one.
Oh.
So command / comments it, and if you just do it again, it uncomments it. So it's like a toggle. Yeah. Yep. There's tons. I mean, in Replit, I don't know. I think there aren't too many shortcuts. But in a lot of the text editors that programmers use, there's hundreds of shortcuts, of which I know very few. I learn a new one every so often when another programmer watches me type something. Like, you don't have to type that all out. You can just do, Command Control H. I'm like, oh, I had no idea. Other questions? Okay, let me save this and Slack this out as well to general. Not that. That. Okay, let's put this in and see if that stops that psychedelic virus. Yeah. Ooh. Talk about seizures. Oh, man. So the hardest part of this exercise is concentrating while this is going on. That's for sure the hardest part. So to unlock virus 3, this is a very dangerous virus, as you can all tell. So we definitely need to stop this one. We need to fill in a box with a function called virus that accepts an array and returns the reverse array. For example, if the input is 1, 2, 3, the output should be 3, 2, 1. This is a hard question. I know that because this is a programming interview question. In fact, it's a programming interview question that I've been asked on an interview and somehow bungled my way through it. No, but really, it's hard. It's hard. I mean, this is a hard question. It's even harder when people are staring at you solving it. But yeah, in this context, I'm not so intimidated. But when it's people who are deciding whether you get the job staring at you doing this, it can be hard. But this is one of those classic, just like FizzBuzz. This is a classic. It's a classic programming interview question. And apparently, it's also a virus in Quizzikistan. So we are going to solve this one. Now, if I was really making a function that did this, I might call it reverse or something like that. But our instructions are that it must be called virus. Let's just demonstrate how this would be used. So if we did p virus and throw in 1, 2, 3, 4, 5, then our expected output would be 5, 4, 3, 2, 1. So far, so good? Since the input is an array, I'm going to go with my favorite input array variable name to be the receiver of that input. Okay, since we want to return an array, I'm going to go back to my trick of starting off with a new array that's blank. Now eventually, jumping to the end, I'm going to make that my output, right? The hard part's all the stuff in the middle. So somehow we want to be able to get a reverse version of this array. So there are perhaps a number of ways to do it. There's many ways to do it, although I haven't taught you everything you need to know for all the ways. But there's at least one way that we can all do based on all the stuff we've learned. The strategy that I'm going to do here is, and this is sort of unusual, I don't know if I've demoed this concept before, but it's nothing too original. Typically, every time we've looped through the array, we've started from the left-hand side, right? We made a variable before the loop called index, right? And we said index is 0. And every time we pass through the loop, we increase index by 1, so we can inspect input array 0, input array 1, input array 2, etc. In this, the strategy I'm going to go with here is I'm going to start the index at the end. And every time I go through the loop, I'm going to subtract 1. And so my loop is going to start with the 5, shovel it into the array. Then it's going to get to the 4 and shovel that into the array. Then it's going to look at the 3 and shovel that into the array. And effectively, we reverse the array because we're shoveling them in backwards. Does that general strategy make any sense? Any questions about that strategy? Okay. So to do so, my index will not start at 0. I want to start on the right-hand of the array, right-hand side of the array. How do I, now if I knew that my array would have 5 elements, I would set my index to be 4, right? Because it's 0, 1, 2, 3, 4. Index 4 is the last item. Question is, how do I do this if I want my function to be flexible? How do I always get to the last item of the array? How do I find the last index if I don't know the length of my array? Or if I don't know how many, so any advice on that?
Just like the trick you did earlier where you found the length of your total array as it was.
So we know that we could actually check to see how many items there are in the array with this trick of input array.length. So if I said index is input array.length, what number would this be? What would my index be?
5.
It would be 5. But what do I want the index to be?
4.
4 because it starts at 0. So how do I get to there?
Subtract by 1.
I subtract 1. So however long my array is, I can always get to the last index. If my array has 10 things in it, then array.length minus 1, which is 9, that will always be the last index in my array. Does that make sense? Yeah.
So Ruby knows .length?
Yeah, so that's one thing I showed earlier today was this new trick that if you do this .length, you attach it to the end of your array, it gives you the number of how many items there are in the array. So Ruby knows that. That was a new trick I introduced today. Yep. So we're taking advantage of that trick to find the last index. We're going to start from the last index and then keep on subtracting it by 1, and then thereby going through this array backwards and then shoveling each one into the new array. Does that make sense? So now, again, to keep this flexible, how many times are we going to run this loop? We're going to run as many times as there are items in this array. So number of loops is going to be input array .length. And now we're going to run that loop. Number of loops times do. As we said, we're going to subtract 1 each time you go through the loop. So in this example, the index starts out as 4. We're going to shovel into the new array, input array, index. I think we're done. That's it. So let's walk. This is actually the complete solution, but let's walk through it. So in this example, where we have 5 things in the array, the index is 4. We then run this loop 5 times. We start with input array 4, which is the last item. We shovel that into the new array. So if I was keeping track of the new array down here, there's going to be a 5 in it. We then subtract index by 1, so now index is 3. As we go around to start the loop again, we say, okay, what's input array 3? Oh, it's this number 4. Shovel it into the new array. And remember, every time we shovel it in, it goes to the end of that new array. And then index becomes 2. So the next time we run the loop, input array 2 is the 3. So we're effectively moving backwards through the array. And then we're shoveling it in. So by the time we're done, we end up with the reversed version of the array. Does this make any sense? Now, if I had to take an interview again, I'd be a little more prepared. But yeah, this is hard stuff. Any questions about this? Okay, let's see if this stops that virus. Boom, all viri deactivated. Okay, is it funny? Okay, tried to find, I was like Googling funny virus videos. I had to go through a bunch of them until I found one that I found was at least semi-amusing. Okay. New topic. We're almost at the end. The next thing we're going to talk about is caches. And then tomorrow we're going to talk about APIs, which is going to be super fun.
We talk about, is it a GitHub?
GitHub, yeah.
What is that?
Yeah. That's not in the curriculum, but briefly, GitHub is a website that is a place where people store code online. So I'm already logged into GitHub. So I could actually show you the code for the Kazakhstan website right now. So I have it stored online. Think of it as just like the place to store code online. So here is, I call it the hacked app. This is the code for the Ruby on Rails website. What's that?
Put so much work
No, I mean, I would like to say yes, but it's once you know how to do this, it's really, I did this in a very short time. So just to show you like the code that ran the exercises that we just did, I don't want to give too much away over here. Oh, these were those massive, remember the massive numbers you had to throw in? I was checking if your result was that. It had to be exactly that. Whoops. So in this one, look what I did. I called, so in the first, you made a function called virus, right? So I said if when I run your virus function, if I pass in as the input 1, 2, 3, the result is an empty array. This was, again, the first question was getting an array of all the numbers greater than 7. So I was saying if your virus function, when you pass in 1, 2, 3, if the output is an empty array, and if you did this example, virus 5892, the result was an array of 8, 9, then go on to the next level. Otherwise, redirect back to the original virus page. So this is the code for that website. And then here, in the second one where you had to, we counted up the number of 55s. So I said, when I run your virus function, if I pass in as an input 1, 2, 3, if I get back 0, because there are 0 55s in that array, and if I put this array in there as input, I get 3 back because there are 3 55s, that means you got it right. So move on to the next level. Otherwise, go back to the virus page. And then in this one, seeing when you put in 654, it's 456. If when you put in 293, it's 392. Checking out that it's right. So if you go to the Bootcamp, you can actually learn how to make the Quizikistan website. Yes? Yes, Josh?
The last example that we just did with, with the reverse,
yeah.
Like we used a different method.
Yeah.
And so my question is though, how in your code for the website, how does it know that our method was okay and the method that you just did?
Yeah, so the way this is working, great question. The way this is working is all this code says, I'm running your virus function. I'm passing this input into it. If I get my expected output, that means you're right.
Okay.
This code doesn't look how you did it. It doesn't know how you did it. It just treats it as this black box machine. I'm throwing in the input. If the output is what I want it to be, that means it's good.
We just ran on that one, we ran it and came up with the array and then put dot reverse on the output.
So that's the cheating way. I didn't teach you that. But now you know how dot reverse works. I mean, yeah.
Right. So we didn't know if we were taught that yet, but
you were not taught that.
Okay.
That was downright cheating. But it's good enough. It's good enough. See, this is not catching that. It's just saying, hey, your machine worked. It outputted the expected output, so it's good.
See, you should update it now saying you see a dot reverse.
Yeah, so I can make this more sophisticated and inspect your code, but that's not worth my time.
you can look it up online.
Yeah.
You taught in class. So
I taught it?
you taught the dot reverse in class.
I regret teaching that. Sorry, that's a very long answer to your question, Evelyn. GitHub is a place where you store your code online. There's 3 reasons why you'd want to store your code online. One is just for backup. So if, God forbid, my computer blows up because of a Quizikistanian virus, at least my code is still online. Number 2 is that GitHub is built in a way where you can easily collaborate with other team members. So let's say 2 of us are working on this website together. I make changes, put it up here, you pull it down, make your changes, you put it up here, and it allows for easy collaboration. And the third reason why GitHub is useful is, I know there's a third reason. The third reason is it's a way to look at other people's code and learn from them. So, what's that? Oh, thought I heard something. So, that's what GitHub is. We're not doing it in this.
From there, like CDNs, or like if your website's calling a package on another server, like JSON.
Yeah, you could do that. You could pull from GitHub. Yeah. Yeah, and you can also use GitHub. I guess a fourth thing. You can use GitHub as the basis to deploy your website and make it live. So I use another service called Heroku that takes this code from GitHub and makes the website as a real live website, which is the one that you are all using. Yeah, so that's GitHub. In the bootcamp, we all use GitHub, but it's not something we're getting to in these 2 weeks. But we are going to get to hashes right now. So hashes is a new data structure. So yesterday we learned about our first data structure, the array. Right? The array essentially is the concept of a list. It's a list of items. A hash is another kind of data structure that is also a list, but instead of a list of single items, it's a list of items that belong in pairs. Let me demonstrate. And let me save this and Slack it to general just so you have it as reference. Okay. Here is the concept of a hash. It's a list of paired items.
An example of that perhaps be, say, coordinates on an XY plane.
Yes, that would be a great example. I'm going to show you an example of a menu and its prices. So let's say I go to a fast food place. A hot dog, what does a hot dog cost these days? $1.50? $8? So you should start going to Kale's place. Hamburger, how much does that cost? Well, I guess it's going to be a difference. $12? Okay. Fries? Anybody? $4. Okay. I'll just get 5 hot dogs, please. So this is a hash. So it's a list, whereas an array is a list of single items, a hash is a list of items that belong in pairs. So again, just like in an array where each item is separated by a comma, in a hash, each pair is separated by a comma. The reason these pairs are associated with each other are to indicate that a hot dog costs $1.50, and a hamburger costs $12, and fries cost $4. So these pairs are associated with one another. So an array is great if you want to list like a shopping list, a list of single items. But a hash is great if you want a list of items that belong in pairs, like 2 pairs of information that are connected to each other. Let me show you another example. So we can make a dictionary where we'll have, I should have prepared for this example. So that's a good thing we can, a bug. The definition of bug is little slimy creature. And we can define book as thing you read with pages. This is a very descriptive dictionary. And blue is a color. Okay, so excuse my poor dictionary. But the point here is that a dictionary is another example of where you have a list of paired things. We have the word and its definition. It's a list of pairs. It's a list of food items and their prices. It's a list of words and their definitions. So it's like an array, but it's just a list of pairs that are connected rather than a list of individual items. Does this concept make sense? In some languages, by the way, like Python, they don't call this a hash. They actually call it a dictionary. That's what they call this data structure. In other languages, they call it hash tables or hash maps. In Ruby, they're called hashes. Any questions about this? Also note that with hashes, instead of using square braces to delineate them, we use these curly braces. Okay. Now let me actually show you the most common usage for a hash. A hash makes a great way to describe a person or an object. Forget person, scratch that. To describe an object. So we're going to say Joe. Joe his hair is black. His height is 5.8 inches. No, I don't know, 5.8 something. His weight is 180 pounds. His et cetera, et cetera, et cetera. His ears are 2. His 2 ears. So a hash is a great way to describe something because it's pairing together an attribute and basically the value of that attribute. So Joe's hair is black. His height is 5'8". His weight is 180. His ears are 2. Does that make sense? So hashes are used for all different types of things. But this usage as a description for an object is probably its most common usage. But it could be great for a menu, could be great for a dictionary. Shane mentioned lat long, but I probably wouldn't use a hash alone just for that. I'd probably use something more complicated. Let's do my car, or not my car, but someone's car. So the make is a Honda, the model is an Accord, and the year that it was made in is 2006. Yeah?
Equal greater is just for readability?
Oh, sorry, I should have pointed that out. So every pair, so each pair as a unit is separated by a comma. But to divide the first item from the second item of the pair, we use this arrow called a hash rocket of all things. Yep, so that's just how you separate the two items of the pair. Now the arrows do indicate its forward-facing nature, meaning we pretty much go forward in all these examples, right? I wouldn't say Joe's black is hair, right? Or that my 2006 is year, right? Hashes usually go forward. So the make is a Honda, the model is an Accord, a bug is a little slimy creature, a hot dog costs $1.50. So you read it in the direction of that arrow.
Would it change things if, like, I just realized, like, I was putting quotation marks around all of the numbers, like the 1.5 and the 12 and the 4?
Yeah, you could.
Like, is it just more work for you?
It's just a matter of what you want to do with these hashes in your code.
Okay.
So if I wanted to add Joe's height to someone else's height, it wouldn't work unless I converted it to a number first, because only then can you add the numbers together. So it really depends what you want. If you just want to view it, then it doesn't really matter. But if you want to do math with it, then you'll want those to be the numbers. Great question, yeah. Now, just to get some jargon out of the way, in every pair, the first item of a pair is called a key, and the second item is called a value. So let's take Joe. Hair is a key, and the value is black. Height is a key, and the value for that key is 5.8. The weight is the key, and 180 is the value. Ears is the key, and the value is 2. So that's just a definition. That's just how it's called. So that's what they decided to name these things. Keys and values. So if I were to say this in a very jargony way, I would say a hash is a list of pairs of keys and values. But that doesn't really mean anything to anyone. So the way I like to say it is that a hash is a list of paired items that have associations with each other, which also might not mean much to someone. But hopefully these examples make it more sensible. Any other questions about this? Okay, now let me just show you a little bit more how to use hashes. So this is how you set up hashes. What if I had Joe, and I specifically wanted to look up his hair? So this is how you do it. If I run the code, it prints out black. So let's digest this. The first weird thing to point out is that we made a whole big stink about how arrays are used. We use square brackets to delineate arrays, and we use curly braces to delineate hashes. However, when you're looking up a value inside a hash, ironically, you use square brackets. If I were making a language, I would have made it that you use curly braces like so. However, that's simply not how Ruby was designed, based on arbitrary, I don't know what. So to look up, you can look up a value by its key. You cannot go in reverse, by the way. If I want to look up a value, I will not get its key. I get this thing called nil, which basically means non-existent. So this is another funny thing about hashes. It's one-directionalness. I can look up a key and get back its value, but not the reverse. So if I want to look up the definition for bug, that's how I do it. So there's nothing complex about this. This is just learning new sets of rules. A new data structure, and these are the rules of how you use it. One more rule. If I want to add a key value pair to an existing hash, let's say I wanted to add another detail about my car. There you go. How do you know? You see my car? So you do it like this. Again, using the square braces, the square brackets. And this looks very similar to setting a variable, right? We say something equals something. However, we're not setting a variable. What we're doing is we are establishing a new key value pair. We're saying add this key and this associated value to the hash. So actually, if I were now to print out the car hash, it would look like this. This key value has now been added to my hash. So it's a weird syntax, but it's not. It's very analogous to an array. Not to bring back bad memories, but if I had an array here that was empty, and I wanted to add something to it, we use the shovel, but I could also say I want the thing at index 0 to be 4. So this looks very similar to that. And similarly, if I want to look up an array, if I want to look up what's at array 0, that's what I do. So similarly, that's how you look up something in a hash. People get very confused by this until they use it a lot. It's confusing that we define a hash with curly braces, but then read and write to it with square brackets. If I wanted to make an empty hash, which is something you might do in some algorithms, just like we made an empty array for some of our algorithms and shoveled things into it, I mean, it would basically look like empty hash is an empty set of curly braces. I could then, add things to it, which I have nothing meaningful to add to it, but and it wouldn't be empty anymore. But that was my variable. Poor name from a variable. Questions about this? Okay, I made the choice to not go heavy, because just like I introduced arrays and then showed you all these complex algorithms we could do with arrays, the same applies with hashes. Like hashes are a staple for a lot of these complex algorithms and these interview type questions, but I decided not to go that way. We're going to go light in the hashes. However, I am going to go heavy on the following. I'm going to go heavy on having you get really good at picking apart data. And that's going to be super important for when we deal with APIs tomorrow. So let me show you what on earth I'm talking about. Okay, let's look at this carefully. I have 3 variables, drink 1, drink 2, and drink 3. And each one is referencing its own hash. These hashes are used to describe the particular drink. So the first drink we have is seltzer. How do we know that? Because we can see that there's a key of name. All 3 of these drinks have a key of name, but have different values. So this first drink is seltzer, the second drink is Coca-Cola, the third drink is water. I recommend water, although you'll see me violate this. But tonight, appropriately enough, I have water, unlike last night. So we have, if you look carefully, each hash also has another key called ingredients. But this is where things get hairy. What is the value of each of these ingredients? It's an array. And that's fine. It just gets, there's just lots of brackets and parentheses going on. It's hard to read that. But when dealing with APIs, you want to get really good at that. So we are going to hone that skill today and tomorrow. So the reason we have an array here is because, seltzer, I can't just say either water or bubbles. Those are both important ingredients in seltzer. So really my ingredients is a list of things. So the best way to depict a list is with an array. So my value, instead of being a number or instead of being a string, is an array. It's the array of strings that represent the list of ingredients for seltzer. And I don't know why everyone thinks that Coca-Cola is such a secret recipe. It's very, very simple. It's water, bubbles, sugar, and brown food coloring. Everybody knows that. And water, you might have thought does not have multiple ingredients, but it has hydrogen and oxygen. It's hard to make water. So, does it make sense why this is the way in code to depict these various beverages. But again, it gets tricky. Technically, another way to put this is we have an array inside of a hash, right? By the way, you could have arrays inside of arrays. I didn't really demo that yet. You could have hashes inside of hashes. But we'll get to all this, don't you worry. The next example involves arrays inside hashes inside arrays. But you'll see why. It's not just for the sake of being cruel, although it's partially that. I have here a list of people. These are my closest made-up friends. So since I'm depicting a list of people, I have an array. So before you even look at all this stuff in the middle, right, if I want to introduce to you a list of people, it makes sense to have an array. Array is the best way to make a list. Now, this array, instead of being an array of numbers or array of string, is an array of hashes. This array has 3 things in it. It has 3 hashes. Can you see that? It's this first hash separated by a comma, second hash separated by a comma, and a third hash. If I did, remember my trick, array.length? What's it going to say? It's going to say 3. There are 3 things in this array. People.length. There's 3 things here. 3 hashes. But you can see how it's sort of hard to make that out. Right? It's hard to see that. But if you look carefully, you can see it. Now, digging into each person, so each one of these hashes represents a person. This person is Bob Jones, whose hobbies are basketball, chess, and phone tag. He's an annoying friend. This second person, Molly Barker, loves programming, reading, and jogging. She likes doing it all at the same time. She's very, very talented. Kelly Miller, a little eclectic. She does cricket, baking, and stamp collecting. Yeah?
Are the indices measured the same as in the arrays? So like if you were saying, give me all the hobbies.
It would be 0, 1, and 2?
0, 1.
Absolutely. So I'm going to demo that right now. Yeah, great question. So let me make this a little smaller. Does what I just described fit with what you see here? Does this make sense?
Yes.
Can you see how this can be very confusing? But this actually is the right. This is not purposely obtuse. This is the right way to describe this in terms of data. Okay. So now getting to Joseph's question, how would we, I'm gonna back up to the simpler example first, before we get to the more complex one. If I wanted to single out water, if I wanted to get the program to print out water, I mean, obviously I could say print water, but that's not the point here. If I want the program to sort of zero in and grab the water from within this array, watch this carefully, this magic trick, right? Drink 1, right? What does drink 1 give me? It gives me that hash, right? Let me, that. Right, I get the hash, right? Now, if I want to get to the water is contained within an array, and this array is a value for the key of ingredients, right? So if I do this, what do I get? So whenever you look up a key in a hash, you get its value. In this case, the value is not a particular string, but it's an array of strings. Now what do I need to do to get water? Yeah. So I got my water like that. Because you just have to break it down. And here Ruby processes it from left to right. So drink 1 gives me this hash. Drink 1 ingredients gives me this array. Now that I have this array, if I call this bracket 0 on it, I will get my water. If I want bubbles instead, I change that to a 1. If I want to get brown food coloring, I need to reference drink 2's ingredients and grab index 3. Does this make sense? Again, there's nothing complex. It's just like this is how you access data. This is real world programming, by the way. This is stuff you do all the time. Taking this to the more complex, well, before we do that, any questions? Taking this to the more complex example, what would I need to do to grab stamp collecting? So help me out here. Okay. Now, I need to show you my trick. My trick is, whenever I do this, This is, by the way, standing on table worthy, but I can't use that all the time. But this is something I'd stand on the table for. This trick, remember this trick. As I'm trying to dig into this data, don't try to guess it in one shot. It's really hard. Do it one at a time. So I'm going to start with people and see what I get. Okay, I get this array. Now, again, I want to get to stamp collecting. How do I get there? I need to get to this hash. How do I get to this hash? This is a hard question. 2, because 0, array start at 0. 0, 1, 2. But instead of me going on to hobbies, blah, 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 stop. Just run this and see what you get. See if you're zeroing in on it. And I see I am zeroing in on it because stamp collection is there. Stamp collecting is there. If I messed up and I did people 3 and run it, I get nil. I mean, if I didn't stop here and I went on and blah, 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 imagine, let's say I did, hobbies, 2, last name, obviously I'm doing this wrong, but like, I see there's an error, but I don't know where I'm off, right? And then I have to like go, like it's like a maze. So don't do that. Just do one step at a time and see every time you add something to this list, see if what you're looking for is still there. This is an extremely valuable pro tip. Remember it. So people 3 is nil. So we already know we messed up. So let's back up. Let's do hobbies 2. Okay, I see stamp collecting is in our sites. But we need to zero in further because all we want to get back is just stamp collecting alone. So what do I need to do next? So since what I have back is this hash, to get at this value, I need to do hobbies like you just mentioned. So good call. Now, what should I do next? Yeah, just run it. Just run it. Yeah, okay. It's still there. Stamp collecting is there. We're getting closer. I'm telling you this trick is golden. This trick is golden. Okay. Now, what do I need to do next? Index 2. Boom. Stamp collecting. So that's how you do it. This is real data work. So yeah. So we're gonna have a bunch of exercises where you get to do some of this fun stuff. But let's just take a quick break. We'll start at 8:40. So, of course, this exercise is naturally going to be much harder than anything we did in hashes so far. Here, I'm going to slack this to you. You're going to shudder. But this is representative of what a real API looks like. Again, we're going to dig into APIs more specifically tomorrow. I just slacked this to you in general, but I'll pull it up here as well. This is a large hash with arrays and hashes all mixed up in each other that represents the weather, the current weather in Nome, Alaska, which you probably were all wondering what the weather is. So at least as of earlier today, it was 46 degrees. You have to find that in there. So as part of this exercise, you should probably spend a minute or two just looking through the whole hash, feeling your way around, getting a sense of what information is here. But then your specific exercise is to write code that pulls information out of this hash. Right? Just like here, we pulled the stamp collecting hobby out of this array. So I want you to, now I'm slacking to the actual exercise, write code that gets me the wind chill, the longitude of Nome, Alaska, the current temperature. Now the current temperature, I showed you where that is. It's here. Inside condition, inside item. I mean, it's really nested deep in there. And also get the high temperature for next Sunday. If you look here, one of the sections of this is the 10-day forecast. which is an array. Each hash represents a day. So this is the forecast for Wednesday, and Thursday, and Friday. So I want the high for Saturday. So I want you to write the code for all these things on the bottom of this, and then you can go ahead and Slack me your results. Is that clear what I'm asking for? Yeah.
Well, sorry, again, one more time, wind chill, temp, high.
Oh, I slacked it to you. It's wind chill, longitude, current temperature, and the high for next Sunday. But I slacked it in general. So basically you're writing 4 lines of code on the bottom of all this that pulls out those very specific pieces of data.
Can you send the example you had?
Yes.
We were just looking at?
Yeah. This one?
Yeah.
Yeah. So here I'm saving and slacking to you the people.
Jim.
Yeah.
So you print these out maybe?
Yeah, so write code just like what you see up here on line 19. I wrote code that gave me back stamp collecting. So I want you to write like 4 lines like that, where it simply prints out these 4 pieces of data. Does that make sense?
Yeah, everything's all good.
Okay. Sometimes I think I'm hearing voices.